Today's lesson is Chapter 9, Lesson 4, Changes in Dimension. Our goal to accomplish after this lesson is to be able to determine the effects. So what happens when you change dimensions on perimeter and area? Okay, so the first thing that we're going to look at is if you change the dimensions. So if you change the length or the width, what would happen to the perimeter? So our main focus for this one is the perimeter. So in words, if I'm going to read it in words, if the dimensions of a polygon, remember a polygon is a figure, a closed figure with 3 or more sides. If the dimensions of a polygon are multiplied by x, remember x could be any number, it's just a variable, then the perimeter of the polygon changes by a factor of x. Okay? So notice our model. I have my first picture, the sides are 3, 3, and 2. And then my next picture, my sides are 6, 6, and 4. So what happened? I have to look at each side. So from 3 to 6, what did I do? Well, I multiplied by 2. Let's see if they're all multiplied by 2. That one is. 2 to 4, that one is. Okay, so I noticed that I just doubled or multiplied by 2 the dimensions. Okay, so for perimeter, if I was to add all of these up, 3 plus 3 plus 2, I would get 8. If I was to do the perimeter of this one, the bigger one, the one that we doubled, 6 plus 6 plus 4 is going to give me 16. What do you notice about my 8 and my 16? It's just doubled. So if I double the dimensions, my perimeter will also double. So if I did them times 3, my perimeter would go up times 3. So whatever you did to the objects or the figures, that's what would happen to the perimeter. Now keep in mind that's just the perimeter, not the area. Okay, let's try a sample problem. Suppose the side lengths of the trapezoid at the right are multiplied by 1/2. Okay, so on the last one, we doubled them or we multiplied them by 2. This time we're going to multiply them by 1/2. What effect would this have on the perimeter? Justify your answer. Okay, so this is my first one. My second one I'm going to draw, we have to draw it where the dimensions are multiplied by 1/2. Okay, we've talked about that multiplying by something by 1/2 is the same as dividing it by 2, but I want to show you that I'm going to multiply everything by 1/2 to get my new dimensions. Okay, so 13 by 1/2, I know that just cuts it in half, so half of 12 is 6 and half of 14 is 7, so I know that it's in between 6 and 7, so 6.5. Then I'm going to do half of 24, I know that one is 12. Half of 14 is 7, and half of 14 is 7. Okay, so this is my new trapezoid with my new dimensions. So if I'm going to find the perimeter, what's going on with the perimeter, I need to add up all these sides in order to find out my perimeter. So I need to add 13, 14, 14, and 24. I have 3 4s here. I know that 3 times 4 is 12. So 12 plus 3 would be 12, 13, 14, 15. Carry my 1. 1, 2, 3, 4, 5, 6. 65 is my perimeter. Okay, so that's for this trapezoid, my first one. Well, we just learned in the previous slide that whatever you do to the dimensions, the same thing happens to the perimeter. So if I multiplied my dimensions by 1/2, I can do the same thing with my perimeter. So my first one is 65. So I'm going to take 65 times 1/2, and I'm just going to change that 1/2 to a decimal, 0.5. So 5 times 5 is 25. 5 times 6 is 30, plus 2 is 32. There's one decimal spot, so 32.5 would be the new perimeter. And that makes sense because look at all of my dimensions. They got smaller. Remember, if you multiply by half, it's the same thing as dividing by 2. So everything got smaller, so obviously my perimeter has to get smaller. Okay, so something you want to write down maybe is that perimeter, whatever you do to the dimensions, that's what you're going to multiply the perimeter by. So if you times it by 2, you're going to times it the perimeter by 2. If you times them by 3, you're going to multiply the perimeter by 3. If you multiply them by 1/3, you multiply the perimeter by 1/3. Okay? So whatever you do to the dimensions, you do to the perimeter. Okay, this time we're going to focus on area instead of perimeter. So this one's going to be different because for area, you're finding the whole space, not just the outside edge. So if the dimensions of a polygon are multiplied by x, remember x can be any number we want it to be, but we don't know, then the area of the polygon changes by x times x, or x squared. Okay, so instead of just saying if we doubled it, we would just double the perimeter. This time if we did it times 2, we would have to do it times 2 squared, or by times 4. Okay, so hopefully I can explain this to you. So I have 2 squares here. My first figure is 4 by 5. And for area, I do length times width, or base times height. So I'm going to do 4 times 5, and that gives me 20. Okay, so this whole space is 20. Well, what did I do to each dimension? I times it by 2. So if I times it by 2, I have 4 times 2 is 8, and 5 times 2 is 10. Okay, but let's see what happens to the perimeter. Or not the perimeter, the area. So let's see what happens to this whole space. Let's see if it doubles or if something else happens. So I'm going to do 8 times 10, and that gives me 80. Okay, well last time we said to figure out what happens, you just have to double what you got on the first one, and that's what you get for your second one. Well, I see I have 20 and I have 80. That's not quite doubled, because if I doubled 20, I would get 40. So they're telling us up here, if you can see that, they're telling us right up here that, let me get my pen back out, that if we take x squared, that will help us. So we said we doubled it. Okay, we did times 2. So 2 is our x, because we did times 2. So 2 squared equals 4. So 4 is what I'm going to multiply it by. So 20 times 4 would give me that 80. 20 times 4 equals 80. Okay, and they show that right down here at the bottom. So instead of just taking whatever you did to your dimensions, like here we did times 2, and for perimeter we used to just take the first one times 2 to get the second one. Well, here we're not going to just do it times 2. We're going to take that 2, we're going to square it, then we use that number to multiply. Okay, so let's try it with this problem. Ignore the stop signs. Right now we have a problem up top. A rectangle measures 2 feet by 4 feet. So 2 feet by 4 feet. I usually like to draw it out whenever I have a word problem and they don't give me a picture, just so I can see it a little bit better. Okay, 2 feet by 4 feet, that means the area is going to be 8. Suppose the side lengths are multiplied by 2.5. What effect would this have on the area? Okay, so I need to take 2 times 2.5 to get my new length here. 2 times 2.5, and that's going to give me 5. And then I need to do 4 times 2.5 as well. So I'm going to do 4 times 2.5, and that's going to give me 10. Okay, so my new area is 5 times 10, which is 50. Well, how do I get from 8 to 50? Okay, you need to know what's going on with this 8 and what's going on with this 50. You have to explain that. Well, what we did is we took that times 2.5 and we need to square it. So 2.5 times 2.5 is going to get us 6.25. Okay? So what I did is I did 8 times 6.25, and that's what got me the 50. Okay, so I figured out what I multiplied my dimensions by, I squared it, and I'm going to do that times my original area to get the new area. Okay, so you just have to remember the process or the difference between the area one and the perimeter one. Okay, so perimeter, whatever you do to the dimensions, you're just going to do that to the perimeter. Area, whatever you do to the dimensions, you're going to square that, and that's what you're going to get for your new area. You'll multiply it by your original one. Okay, let's do the stop signs problem now that I'm done erasing. Okay, so a stop sign is in the shape of a regular octagon. As we know, an octagon has 8 sides. Okay. Sign A, shown at the right, has an area of 309 square inches. So let's look. Let's cut these two in half. This one equals 309. What is the area of sign B? So this one, I don't know. Okay, so I need to see what I'm multiplying by to get to 12. Okay, so 8 times 1 is 8, so I didn't multiply by 1. 8 times 2 is 16. Well, that's not 12. So I need to think of a number in between 1 and 2 that it would be multiplied by. Well, typically they like to go in like halves or quarters. So what about 1.5? 8 times 1.5. 8 times 1 is 8, plus 4 is 12. There's one decimal spot. Oh, that one works, okay? So it's getting multiplied by 1.5. Okay, so I figured that out. It's getting multiplied by 1.5. Okay, but I need to figure out the area. So how I'm going to do that is I'm going to figure out what 1.5 squared is, because that's what we do when we're doing the area. We figure out what it is squared. I know 1.5 times 1.5 equals 2.25. So that's what I need to multiply my original area by, and that will give me my new area. So right down here it tells you that, and that's going to be 695.25. And a lot of people, if you would look at this, you might think you need to know the formula to find the area of an octagon, but really if you just know what happens to the area when you change the dimensions, that's so much easier, because then you can just multiply it by that number. Okay, these are some practice problems that I want you to solve in your notebooks and bring them to class tomorrow so that when we go over them, you can see how you did for practice. One thing to keep in mind is this is perimeter and this one is area. For this one, you're going to take it x squared. This one, you're just going to take it times x. This is another practice problem that you'll do in your notebooks and we'll go over in class. Different sizes of regular hexagons. Remember, hexagons have 6 sides, hex, 6. So 1, 2, 3, 4, 5, 6. That's a hexagon. Are used in a quilt. Each small hexagon has a side length of 4 inches and an area of 41.6. Okay, so that's your original picture. Each large hexagon, so I'll make this one a little bit bigger, has side lengths of 8 inches. What is the area of the large hexagon? Okay, so you need to figure out what's going on here, what it's getting multiplied by, and then you'll figure out, this is 41.6, what the new area is over here. So our goal, hopefully today we accomplished our goal, is to determine the effects of changing dimensions. So realizing what happens to the lengths. If we go from a 4 side length to an 8 side length, we're multiplying it by 2. And then seeing how that affects the perimeter. Does it double it? Does it multiply it by a certain number? So being able to determine what happens to the perimeter and what happens to the area. If you can do those things, that's great, and you've accomplished this lesson. A reminder you might want to put on your notebook is you're going to multiply by x, and you're going to do multiplied by x squared for the area.